So the new session is start now. And is there anything left from day before you want me to discuss?
No, no, not at the moment. No, it's all okay for now. I might need some pointers when I come to do the assignment, but no, I'm okay with it.
Okay, that's fine. That's good. And normally everything would be dealt with database designing, and with an example of MS Access, MS SQL, whatsoever, and from table creation to the queries and results. It should be smooth as it because this is not a kind of complex database architecture. If it was a different kind of architecture, then obviously it would have been difficult, but it's a basic one. You can get the examples, you know case studies related with the scenario in the assignment or for the study purpose. Lots of stuff is available.
Okay.
Yeah. So
Yeah.
now, so today we start system analysis and design, and yesterday we gave a little touch like a unified modeling language, and in order to represent every kind of requirements, you need some diagrams. Yeah. And diagrams is basically the language. We called it a language of representation. So this unit is purely related with the system analysis and design. The learning outcome one is understand system analysis and design, and two is the be able to use systems analysis and design techniques to recommend improvements to an existing system, and third one is develop a solution to improve an existing system. So before I start, do you have any idea of system analysis and design?
It's basically where somebody sort of looks at your system, isn't it, and looks at the business processes, and recommends changes and helps you implement them.
No, that's the later stage. But in simple words, how would you say something about the system analysis and design?
It would be you would analyze the system and maybe look at improvements, recommend improvements.
Analyze is fine. And what happens basically, in order to create or build any system, you need to know the requirements. Yeah. And you define the requirements in kind of verbal form. Verbal in a sense like in written, or verbal in English language or any language, linguistic. Then basically when you analyze, then you create the diagrams. Yeah. And
Okay.
yeah, you create the diagrams in the analysis. And further, when you refine those diagrams and make them concrete, that becomes design.
Okay.
Yeah. So
Yeah.
analysis and design is both the conversion of requirements into diagrammatical language. Yeah. Analysis at the analysis level, you create the diagrams, and at the design level, you know make more concrete diagrams, probably the more connections in between them. So that's it. And obviously, like this unit says, the uh, improving the system using system analysis and design, that may be possible, but that's not related with the system analysis and design in the worldwide. Yeah. As this unit is being taught to design the system. Design doesn't mean the implement the system. Yeah, but
Okay.
but to give an architectural overview of the system. Is that clear?
Yeah. Okay. Yeah. I've
Yeah.
got that. Yeah. Yeah.
Yeah. So for example, if you are the system analyst and designer, it means you are not related with the implementation at all. Yeah. You are the bare, simple architect who would design the, you know, uh, design the system.
Okay. Yeah.
Right. So last time, if you remember, I said that sometimes we mix up the word. I have designed this, system, and they normally talk about the implementation. Yeah. Who has when we say that, for example, this is a bicycle, yeah, or this is a car. Somebody would say, who has designed this? The car. For example, if we say the Fiat Pinto, for example, if we take an example of the car. So, which car is, for example, you like
I've got a Ford Focus.
Ford Focus. So, when
Yeah.
you say that I'm using the car, design the Ford Focus, car designed by the Ford. Yeah.
Yeah.
Normally you talk about the implementation, but the design would have been done, by some engineers, theoretically and then diagrammatically. Yeah. So uh, normally the what I want to say is that the word design is mostly used for the implemented thing, but technically design is not the implementation. It is the manufacturing, details in the form of kind of design. You understand what
Okay.
I mean?
Yeah. I get. Yeah. I get what you're saying now.
Yeah.
Yeah.
Okay, good. So let us start some slides. So there is a definition: software development. Yeah. Now the software development is the process of developing a software through successive plans in an orderly way. This process includes not only the actual writing of the code but also preparation of requirements and objectives. So, as I explained, that it's not only the writing of the code and implementation, the everything, the development, but it comes through certain process, and the objectives that comes through that uh, comes through the preparation of requirements and objectives and design of what is to be coded. So it is important. It's not necessary to say that this is implemented, but the design said that what is implemented, and confirmation that what is developed has met the objectives. That's most important. So by passing through this process of the software development, you follow the design, and also you try to check that whether the requirements comply with the implementation or not, or the implementation complies with the requirement or not. Simple definitions. Yeah.
Okay. Yeah.
Now this software development should come through the kind of system development life cycle. Yeah. So every process has a life cycle. Do you agree?
Yeah.
Also referred to as the application development lifecycle, is a term used in the system engineering, information systems, and software engineering to describe a process for planning, creating, testing, deploying an information system. When it says anything, any software from engineering, any system, or any the technical thing, it comes through the process of when you plan first, then you create, you test it, deploy it. That's the system development life cycle. Basically, there's a project management model that defines the stages involved in bringing a project from inception to completion. Yeah. So a framework that describes the activities performed at each stage of software development. Yeah. So obviously, you cannot go ahead without any well-defined system development life cycle. So normally it starts with planning. Planning also includes the feasibility study, whether the plan you have, is it feasible or not. Then you analyze the system. Yeah. You analyze the requirements as well. Yeah. The system requirements have been analyzed in a sense that they are fully taken, defined into certain artifacts. Yeah. Certain artifacts like use cases. Yeah. Have you heard about the use cases?
No, I'm not familiar with a lot of this terminology. I guess, yeah, I'm not entirely sure, to be honest, about
Okay. So the requirements are defined by use cases. Use case is basically the verb, an action carried out by an actor, right? So what happens when you write a kind of requirements for a software? You would, get two things. Yeah. What two things would be there? For example, uh, there would be persons doing some work. Okay. The work would be the verb, and the who would be doing that would be the subject
that. Okay.
in the form of nouns.
Yeah.
Make sense? So
Yeah.
you create a use case in the form of verb and noun. Okay.
Okay. Yeah, we got that now. Yeah.
So that requirement analysis is defined using the use cases, and then you write the system design. Okay. So system design is represented using class diagrams, for example. Yeah. To represent the entities, association diagrams, activity diagrams, collaboration diagrams. Make sense?
Yeah.
So design would be based on the diagrams like a class diagram, the entity relationship diagrams, yeah, or data flow diagrams as well. So that is basically the design. Yeah.
Yeah.
Then implementation is the fourth one. Then integration and testing. Integration in a sense that the implemented thing could be one or more units. Then you need to integrate to them, or maybe integrate with existing system. Also the installation and deployment into the real scenario. Yeah. And maintenance, right?
Okay.
So
Yeah.
like here are more words given, like feasibility, requirement analysis, like integration, deployment. But overall, if you simply see that you have requirements, you create a design, you implement it.
Yeah.
Yeah. And obviously when you test it, then after testing you need some acceptance in a way that it should be error free, and it should be uh, it should be modified and supported basically. Yeah.
Yeah.
Acceptance.
Okay. Yeah.
Yeah. Acceptance in a sense that provide the support and keep on maintaining it, right?
Okay.
Is
Yeah.
that clear?
Yeah.
So is
Yeah.
there
I've got that.
anything
Yeah.
I should explain, because the next few slides would be based on the explanation of these things.
No, that's fine. No. Some of those things there I have heard of before,
Yeah.
but I've not actually done them. I've heard people talk about them, that they're going to do them, or
Yeah.
they've done them, but I've never actually gone through them myself. But I fully understand that bit.
Yeah, and because the words are self-explanatory, like a
Yeah,
you
yeah,
have a plan, okay,
yeah.
but is it feasible? How you would check the feasibility? Obviously, you would check the feasibility based on the number of the people, number of the, the funds available to you, and the time duration.
Mm.
Yeah. So plan is feasible. Okay, that's fine. It's a nice project. Do you have funds? Do you have people to do it? Okay. Do you have time? If you don't have a time, even if you have a money, if you have a people, then it's not feasible.
Yeah. Okay.
Yeah.
Yeah.
And obviously these things will come as a topic wise in detail. And as I explained, that system analysis is the conversion of the written definition into diagrams. Yeah. And design is also the refinement into the analysis.
Okay.
Okay.
Yeah.
And integration and testing, like I said, that you could integrate the individual components, or maybe you wanted to integrate it with the existing system. Yeah. And
Yeah.
if it is a new, all the units are new, then you install the system. Installation and deployment is a kind of same thing. Yeah. And installation is, for example, you uh, install the system from very beginning. Yeah.
Yeah.
Everything new. And deployment is kind of you try to put something, integrate, deploy into any of existing system. Yeah. Into
Yeah.
packages. Yeah, into packages. Deployment is basically the general term that's used for the packaging. Like you produce the softwares in the packaging, and acceptance is that whatever you have given, let the users to use it and get it in works on the hands-on practice. And once done, then you come in the maintenance phase. Maintenance could be weekly, monthly, or whatsoever, depending on the need. Probably it can be a routine maintenance. However, maintenance could be change in the plan, the requirements as well. Yeah.
Yeah. Okay. Yeah.
So project planning, feasibility, that's the I have already explained, so let me go through quickly. It's the high level view of the intended project. So as I explained, planning is written in normal language, then analysis requirements, project, they are the refine the project into goals, into defined functions and operations of intended applications. So like in the analysis, we still write the number of modules, the use cases. Yeah, intended operations means use cases, what verbs would be carried out, analyzed end user informations. Is that clear?
Yeah. Yeah.
So then the design describes the desired features and operations in a detail, including screen layouts, business rules, process diagrams, pseudo code, and other documentation. So is that clear what I said? That in the analysis and design, both are related with the designing of the system. The analysis list out kind of the operations, yeah, in the form of use case, and the design gives a detail in the form of more screen layouts, rules, diagram, even they write a pseudo code as well. You are you clear what is a pseudo code?
So, say that again. Pseudo code.
Yeah, that's called pseudo code.
No, no. What's that?
Pseudo code is basically the algorithm.
Ah, okay.
And what is the algorithm?
That's all the maths, isn't it? The algorithm.
Not really. What happens when you write a program in any programming language? For example, For example, this is a program of Java, and this will only print first program on the screen. Okay. What happens when you wanted to write a, the pseudocode is the code written in human language.
Okay.
Okay. Let's say program starts, then function main print and program. Do you get something from here?
Yeah.
Yeah. So that's called the pseudocode. Pseudocode is the a kind of program. You exactly define the logic of the program, irrespective of any programming language.
Okay.
Yeah. So at the system design level, you define the pseudocode, other documentation, so that could be implemented in any programming language. If you did a system analysis and design, you did well, then it's the responsibility of the coder implementation team. They should be able to implement the analysis of the system using design in any programming language, because they would be following your methodology defined in the logic, in the pseudocode.
Okay. Yeah, I've got that now. Yeah, I've never come across that before, so that's good. Yeah.
Yeah. So these things, even this is a kind of let's say level 4. You are not doing any good programming. We are not doing any programming at the moment, but in the system analysis and design, methodology, yeah, the things are defined in this way in sequence. The next step is for the developers or the coders, right?
Okay. So at level 4, at the moment we're not doing any coding, but we will be later.
I'm not sure. Let me have a look. Maybe yes, there is a coding. Yeah.
Okay. Yeah.
Literally, like when you will be doing the databases, then you are writing using the SQL, structured query language, then you are supposed to do programming, but the SQL programming, that is not a pure programming, but still it's a kind of coding.
Okay.
Yeah. There is another unit, computer programming. There is coding involved.
Okay.
Yeah. So depends, we will, study the coding style. Yeah. And that how the coding should be, like, starting from the pseudocode. Yeah. What the code is, what is a loop. Yeah. What is the if condition, what is the, switch statement, and then we'll definitely select some, select any programming language as well.
Okay, good. Yeah, sounds good. Yeah, that's one of the things that I was looking forward to on this course, actually.
Okay, so maybe soon, after let me look at the computer programming details, and we might need to start this sooner until we reach them.
Okay. Yeah.
So now you have to keep in mind, this is basically the from requirements to analysis, design, and implementation. That is the software development. like the software development goes through these, steps. Yeah.
Okay. Yeah. Yeah.
Now, rest of the stories would be, fallen, in between them. Yeah. And then these few steps: integration and testing, acceptance, installation, maintenance, I already explained to you. Yeah.
Yeah. Okay.
Now, people say you have to go through the analysis, design, implementation, and testing. Then, due to the variety of, methods, like different people have different method, ideas. They have been proposing lots of system development methods or software development methods. Make sense? Everyone
Okay. Yeah.
says do in this way, somebody says do in this way, somebody says,
Yeah.
somebody, let's say for example, if it's a dinner, yeah, some people would say take some drink and then have some, food and some, dessert at the end. Somebody would say have some food first, then have some, drink in the middle, and, some drink in the last, and, dessert in the middle. Is it
Yeah.
possible?
Okay.
Yeah.
Yeah. Yeah.
Any could be, any could be the start. Yeah. And so there has been a variety of introduction of the methods. Normally, they started with the waterfall, V-shape, prototyping model, incremental model, spiral model, and then a kind of, a new terminology came in. Yeah, a new school of thought, that agile development, which introduced the ASD, adaptive software development, feature driven, you know, development, clear crystal, dynamic software development methods, rapid application development, Scrum, extreme programming, rational unified processes. So these, processes have been used by a kind of very senior, developers, even the team of developers, yeah, maybe in the Microsoft, yeah, at
Yeah.
the company level.
Okay.
Okay. We like, in a small class, and a small duration, may not be able to explore its practical, things in just in one example. However, they have been, doing these stuff, lots and lots of stuff, on these things, and it's a kind of, a research, right?
Okay. Yeah.
However, at this stage, just for the understanding, we should our start. For example, the things needs to be, analyzed and designed and implemented, and, some basics of the, methods would be sufficient at this stage, right?
Okay. Yeah.
So the waterfall, and furthermore, these methodologies have been given kind of, kind of classification. It's basically not the theory that these methods definitely fall into this classification, right? Please make it clear that this is not the theory. This is not the kind of, an approved classification, but most of the, people, or some of the writers say in this way. For example, the number of methods we need to discuss, like they have listed here, that talk about SSADM, DSDM, Agile, prototyping, waterfall, V-shape, and spiral. Just, a touch to 5 or 6, right?
Okay. Yeah, I understand what you're saying. Yeah.
Yeah. So, like SSADM is basically the blended methodology. Okay. The RUP is object-oriented methodology. OOAP is the object-oriented methodology. The XP, extreme programming, is under the rapid application development, right? The DSDM was we given to us for the discussion is under the rapid development. Yeah. And then like a Prince methodology, it comes in the organizational oriented. Right. So
Okay.
like I said, that everyone is, trying their own strategy. Yeah. These things have not become the standard yet. Yeah. But they have been keep on trying to, make it kind of standard.
Okay.
Yeah. So
Yeah.
let us give a little touch. Waterfall model. Yeah. Requirement, design, implementation, test, installation, maintenance. I hope you would be very much clear from the requirement, design, implementation, test, installation, and maintenance so far.
Yeah.
Yeah. Now, strength of what? Waterfall model. The first model we are talking now is the waterfall model. It's easy to understand, easy to use, provide structure to inexperienced staff. Milestones are well understood, sets requirements stability, good for management control, works well when quality is more important than the cost. Now, now some deficiencies. This one waterfall model is means you carry on these steps one by one and keep on doing one by one, but it has a deficiency that all requirements must be known upfront. Basically, as the name implies, waterfall. Can you imagine when you fall the water towards the, let's say, stair? Yeah. Do you think the water will come up?
Sorry, can you say that again?
For example, if you are standing at stairs, in a house. Yeah.
Yeah.
If you throw the water downwards, do you think that the water, some drops can come upward?
No.
No. But if you are, standing at the floor and the stair is going up, yeah, if you throw some water, towards up the, stairs, water can still fall.
Yeah, the water's gonna fall. Yeah.
Yeah. Water can come back again. Yeah.
Yeah.
So the waterfall is that you are going in the forward direction from the top position to the lower position. You cannot repeat the steps.
Okay.
Yeah. So if you wanted the requirements, you got the requirements, you lock it. Yeah. The user cannot change the requirements at all.
Okay. Yeah.
Yeah. The if you did the analysis, you spend the time on the analysis, you did it, you cannot do it again. Okay.
Hmm.
When you did the design, you finalize the design, you further move to the implementation, and then after implementation you go to testing and deploy. That is the disadvantage, because no one thought, like at the small scale, they assume that everything should go into the normal flow. Okay.
Okay. Yeah.
So these are the deficiencies that you cannot go back to the previous stage. Yeah.
Yeah.
Now this is giving you a kind of hint that you would require to go back to the other stages. Make sense?
Yeah.
Yeah. So how, when to use waterfall model? Requirements are very well known. Product definition is stable. Technology is understood. Next is V-shaped system development life cycle. Okay. So V-shape on the left hand side is same as it's a variant of waterfall model that emphasizes the verification and validation of the product. Okay. Testing of the product is planned in parallel with corresponding phase of the development. So what happens? Requirement, specification, design, coding, testing. What you need to do at every stage, you verify and validate that whether you are doing it right or not. Is that
Okay.
clear?
Yeah, I see, because the arrows are going across, aren't they?
Yeah, but arrows, this is again is until coding, unit testing, and integration testing and system acceptance testing. This is a continuous number of steps. Yeah,
Okay.
but what they are saying, that requirement you do the before it reaches to the testing. Yeah, then you keep on verify and validate requirement, specification, design, coding. Everything you keep on checking with extra efforts. Is that clear?
Yeah, okay, yeah, I get that now.
Then steps I explained, they are well defined, that analysis, design, and these things. I don't need to repeat, the definition of these steps, because they are same, being taken from every stage, yeah, every
Yep.
model, yeah.
Yep.
Certain strengths emphasized for planning, for verification and validation in early stage of the development. Like, in the waterfall model, we didn't care whether the system would be, verified and validated well or not. You have to go through the implementation. But this model, gave a little touch to the verification and validation at every stage. Yeah.
Mm.
So in bold, in simple words, yeah, and all the definitions, and and obviously weakness is that you cannot do this easily at concurrent events. Obviously, it will be disturbing you. For example, if you have team, if a team member did some work, and somebody is again and again disturbing someone, is it fine? Is it correct? Is it validated? So it would make a.
Hello? Hello?
Hello, yes. So as usual, the connection was dropped.
Okay.
Yeah. I think the control is transferred. Hello.
Hello? I can see your screen now.
Yeah, I think something, the mouse was out of control, and I granted you the control, and well, so I was trying to explain that V-shaped model, it has some weaknesses, that everything like a verification and validation at each stage is not easy to do, is it?
No.
Okay. So that's the problem, that problem with the V-shaped model. Yeah.
Okay. Yeah.
So furthermore, when to use the V-shape? Excellent choice for system requiring high reliability, like a hospital patient control applications. All requirements are known upfront. Solution and technology are known. So when it really it matters that you should not have any chance of mistake in the system. Then each and every of the development step should have been done very cautiously. Yeah.
Yeah. Okay.
Okay. Then next is the prototyping model. Yeah. Prototyping model is basically, you don't go through the requirements, you don't go through the, diagrams and these things. You get, a kind of little requirements, come up with the solution and let the user use it and then further develop it.
Okay.
For example, people, uh, create the softwares, contemporary, yeah, and they say, oh, my name is, this, and I'm a software developer. We have a new company. We are creating a portfolio. We have done, a kind of sample for you. You have a look. If you like it, then we can make a contract, and here it is. Yeah. Or,
Yeah.
or for example, if it is a big competition and people, there are 5 programmers, whoever comes to you with a quick implementation and as a prototype, then, the customers, feel more better instead of waiting until the end product.
Yeah. Okay. Yeah.
Yeah.
Makes sense. Yeah. Yeah.
Yeah. So that's basically the prototyping. Hello.
Hello. I can hear you now.
Yeah. I don't know. I think the application gets buffering and it takes some time to send to the server. So anyways, it's good that the connection doesn't get disconnected. And so prototyping is clear to you now.
Yeah. Yeah. That's fine. Yeah.
Yeah. So now
Yeah.
look at the idea from waterfall. You are helpless to repeat the things. At V shape, you are required to do some what should I say, uh, do verification and validation at the time of the development. And when you really don't want to be the formal, then you adopt the prototyping. Yeah. Get
Okay. Yeah.
little type or little info what type of the software you need, and then build a prototype. Yeah. And then further based on the feedback of the from the user, then you try to systemize, analyze, and further extend the requirements with more and more interactions.
Okay.
Yeah.
Yeah.
So makes sense the
Yeah.
difference between these 3.
Yeah.
Yeah. So, and the fourth one is basically, obviously that has advantages and disadvantages. Yeah. Uh, certain steps have been defined, strengths have been defined. Weakness
The
is obvious.
the screen hasn't changed. It's still on prototyping model.
Okay.
It's still on 18.
ATHE, and it doesn't want to go ahead because it says, that you have studied today a lot.
All right.
Yeah, it's not me. Don't know. That there's a system. Is saying, you have studied a lot, buffered. So that's okay. The next is basically the incremental one, and on the agile software development.
Okay.
Yeah. So today, in today's session, there are 42 slides, and for tomorrow, the next session is a bit shorter. So what I think that we, stop this session and we'll cover, few more slides in the next session. And however, the idea behind the type of models is, given, in these kind of, like a prototyping, V shape, and the waterfall. There is one more, the spiral model. So I think we will discuss, in the next session, and we will have sufficient time.
Okay, I'll speak to you then.
Yeah. So
Okay.
I will send you an email, maybe after 2 days or 1 day, as we discussed earlier, that whenever I would be, available, I would send you an email. We'll confirm the class on the short notice. Yeah.
Yeah. Okay. Yeah. Speak to you soon.
Yeah, and today it's sufficient, and you can, revise it and see how it goes, and you can ask next questions, in the next, session. Yeah.
Yeah, that's fine. Yeah.
Okay then.
Speak to you
Bye.
then. Thanks. Bye.